Look at page 16. Do you notice how the medium moves at a right angle to the direction of the wave, the still water line, and the direction of the motion? This is important to understand about a transverse wave. We'll be talking more about it in class. Wave properties. Water transmits energy in the form of waves. As you discovered in the example of the inner tube floating in the water, matter is not transmitted by waves. A water wave can be modeled by a transverse wave. In a transverse wave, the matter in the medium moves at right angles to the direction the wave travels. Water was the medium of the waves in the pool. You in the inner tube were disturbed by the water because you were resting on the water. As a result, you were displaced in an up and down direction while the waves moved across the surface of the pool. Observe how matter and energy move in waves you create in the activity of the right on the right. We're going to do that activity in class, so we're going to continue reading. When you walk to school or the store, you may cross a number of blocks between your house and your destination. If the blocks are the same size, you encounter intersections at regular intervals. You walk a block and come to an intersection. You walk the same distance again and come to another intersection, over and over. There is a regular pattern to the route you are taking. Similarly, waves can have regular patterns. Imagine riding a roller coaster shaped like waves you just made in that pan. The car you are riding in clanks to the very top of the first hill and races down. Before you can catch your breath and stop screaming, you are racing up the next hill again and again, up and down. Your car moves over a regular pattern of rising and falling tracks. If you could imagine the feeling of this ride without the forward motion, you would feel as if you were bobbing up and down on a water wave. The top of each hill, like the top of a wave, is called the crest. The trough of a wave is the lowest part and is similar to the valley between two hills. If you stop the roller coaster on one hill and measured the distance to the exact same point on the next hill, the distance measured would be the length of one wave, or wavelength. Similarly, the wavelength of a water wave is the distance from crest to crest, or trough to trough, of two neighboring waves. Another property of a wave is its frequency. Frequency is simply the number of times something occurs in a given time. To understand frequency, think about a newspaper route. The people on your route only subscribe to the Sunday paper. Therefore, you deliver papers once every 7 days. The frequency of your newspaper deliveries is on time per week. Now suppose that you talk all the people on your route into subscribing to the daily paper as well. The frequency of your deliveries increases to 7 times per week. Now let's look back at the toy spring activity you did. What happened as you moved your wrist faster and faster? What can you say about the frequency of those waves? What happened to the size of the waves? And here's a picture of an ocean wave showing you the crest and the wavelength. The amount of energy you used when you shook your wrist back and forth also affected the spring toy waves and made by the changing their height or amplitude. Amplitude is 1/2 the height of the wave from crest to the trough. If you had measured the height of the spring toy during the activity, you would have found the amplitude of a transverse wave. The amplitude of a wave is related to the amount of energy put into the wave. In the activity, if you put a lot of energy into the spring toy by shaking it hard, you created waves with large amplitudes. If you put less energy into the spring toy, the waves had a smaller amplitude. As you can see, the amplitude of a wave is not determined by the wave's length or frequency. Do the activity on this page to find out what happens to water waves when you put more energy into them. There's the amplitude. We actually have a demonstration that shows this activity, so we won't actually be doing the activity. We'll have a demonstration. All right, take out your worksheet and answer the questions based on this reading.